Right, we're on to part 3. This is quite a big lesson. We're looking at the natural exponential and the natural logarithm. So there's a few new ideas here. First of all, the natural exponential is the number e is equal to 2.718. So you know the way pi, we've got a symbol for it, but it's actually the number 3.14. In the same way, e is a number 2.718. It's a special number. That's why it's got a name. I'm not going to go into all the properties of it here, but it is quite a special number. The natural logarithm then is if you take log and you use your base e. Now remember before we had a base 10, we had a base 5, base 2, we had lots of different bases. Here our base is going to be the number 2.718. So log base 2.718 or log base e. We have a special name for that. When the base is e, we call it ln, the natural logarithm. So log of x base e, we can call it ln of x, ln of x. So we've got the functions y is equal to e to the x and y is equal to ln of x are the inverse of each other. They're like frenemies. They're always hanging around together, but they cancel each other out. So here's the graphs. The graph of y is equal to e to the x is here. Now we haven't, we've looked at quadratic and cubic graphs up to now. We haven't really looked so much at exponential graphs, but exponential graphs like this one where the power is an x, your basic exponential graphs like this have the special feature that they go through 0, 1 on the y-axis. And then you've got the graph of ln of x. Now we said e and ln are the inverse of each other. Now when graphs are the inverse of each other, they are the reflection of each other across the line y is equal to x. So I'll write a little note on that up here. So y is equal to x is like the mirror line. Now we're going to see this a lot more when we come to functions. We're just kind of touching on it now. So if e to the x goes through 0, 1, ln of x goes through 1, 0. They're the inverse of each other and they're reflections of each other. Right, so what we said was that they cancel each other out. So we can say e to the ln of x, they cancel, you're left with x, and ln of e of x is just x. So they cancel each other out, e and ln. And that's going to be the most useful property we're going to use in this section. The graphs of e to the x and ln of x are going to come up again as we go through the course. Okay, so we've got a couple of questions to do here. Solve each equation, giving your answer to 2 decimal places. I'll pop the laws in there again because it's always useful to have them. So what have we got? We have got e to the something is equal to 4e to the something. So a technique we can use here is we can take ln of both sides. You know the way with an equation, you can multiply both sides by 2 or divide everything by -1, all perfectly valid. Likewise, we can take ln of both sides. So we're going to take ln of e to the 5t and ln of 4e to the 2t plus 1. So just make a little note there that you can add into your study notes. All right, so now we're going to see about using our laws of logs or see if we've got any cancelling happening. We've got an ln of e. Now, we already said that they cancel each other out. So that leaves us just with a 5t on the left. I know it might seem a bit strange that what was a power is now big, but when the ln and e cancel each other out, that is what happens. This ln and this e are not cancelling each other out just yet because the 4 is getting in the way. So what I'm going to do is I'm going to use the first law to change that multiplication, oops, not log, it's ln, to change that multiplication into an addition. All right, so there's not much I can do on the left. I was asked to solve, giving your answer to 2 decimal places. There's not much I can do with that ln of 4, but it's okay, don't panic. There's no unknowns there. There's no letters, there's no t there. So it's actually just a constant. Now I've got ln of e, which cancels, leaving me with 2t plus 1. I'm trying to solve for t, so I should bring the t's together. So I've got 5t. I'm going to subtract 2t there from the right, and I'll have to do the same on the left, leave me with 3t is equal to ln of 4 plus 1. So t is equal to ln of 4 plus 1 divided by 3. Now, that's all numbers. You can just pop that straight into your calculator. I would use the fraction button and put ln. You've got the ln button on your calculator. It should be beside the log button. ln of 4. I'm going to close a bracket after that because the plus 1 is separate and come down to the bottom of my fraction over 3. I have got t is equal to 0.795. What did I say about rounding? 2 decimal places. Well, I better change that. It was 795. So the 9 needs to go up and 7/9 would go up to 80. You have to keep that final 0 there, because if it said 2 decimal places, you actually do have to have 2 decimal places, even if the last one is a 0. Okay, so the second example here is very similar, so hopefully you'll be able to have a go at this one without too much difficulty. Write down your worked example first and then pause the video and have a go. So the fact there that you had a fraction in the denominator might have scared you a little bit, but don't worry, your calculator can do the heavy lifting here. Just use the fraction button, ln on the numerator, and then on the denominator, press the fraction button again and type in 9/4. Right, last set of questions in this video. We have to again solve this equation, 2 decimal places, and what have we got here? Now, in the last equation we had e's, and we had to take ln of both sides, and here we have logs. So what we're going to do here is we're going to get the log on its own. So the first thing I'm going to do is move that -1 across. I'm also going to move the 3/7 across, because I just want the log, the natural log, the ln on its own. So that's 1 divided by 3/7, which is 7/3. Your calculator will help you with that if you're not too sure. So that's 7/3. Okay, so there are 2 ways of proceeding from here, and I'm going to show you both options because I'm not sure which one you prefer and I'm not sure which one you have been learning in school. Both are valid, and I wouldn't say any one is easier than the other. So the first one involves the switcher law. So I'm just going to copy the switcher law in again. So we need to remember that earlier in this video, we said that ln was just log base e. So instead of ln, I can write it as log base e of 5 minus 2x is equal to 7/3. So I've changed my ln to log base e and kept everything else the same. Right, now I'm going to use the switcher law to change this into powers or indices. So I have got my base a is the base here, which is e, to the power of x is the power, and x is on the right hand side, so that's 7/3. And y is this part here, so that's 5 minus 2x. I don't have much space here. I'm going to take this part on the right hand side and I'm going to proceed now with this, because what I've done is I've turned it into an equation that only has one unknown, that's the x. Remember, e is a number, so it's actually not as scary as you might think. Your calculator will do the work for you here. So that -2x, I'm just going to bring it to the right to make it positive. I'll leave the 5 where it is on the right, and I'll bring the e across, and it's going to become minus e to the 7/3. And so then x, to get an x on its own, I'll just divide across by 2. So now we just grab our calculator and use the fraction key, 5 minus. Now, E is above ln on my calculator. So if I press Shift ln, I'll find it. I think it's possibly the same in most of the calculators. So that's e to the power of, the little box opens up for the power. I'm going to do 7 fraction 3 to type in that fraction, and then go down to the bottom of the fraction and over 2. And that gives me minus 2.66. So I said there was 2 ways of doing this. Let's look at option 2. And option 2, we're dealing with logs. So what we could do is do e to the power of both sides. We're coming from here. So we're going to do e on both sides. So e raises to a power of ln of 5 minus 2x is equal to e to the power of 7/3. Now, we already said that e and ln cancel each other out, leaving you with 5 minus 2x is equal to e to the 7/3, which is the same as we had here. So that's going to give us 5 minus e to the 7/3 is equal to 2x. X is equal to 5 minus e to the 7/3 divided by 2, and x is still going to be equal to minus 2.66. So either of those is fine. If you're comfortable with the switcher law from earlier, you might want to do that. But in the previous example, we took ln of both sides. So maybe the easiest next step would be to then, if it's an ln, you can do e of both sides, or e to the power of both sides. Right, so this next one here for you has got 2 logs. We've got a subtraction, so I think pull in your laws of logs there to turn that subtraction into a I don't want to give away all the secrets. And then we've got a number on the right, so which is a bit like we have in this line here. So follow my steps, choose which option you want. You probably don't need to write down both in your notes. Choose whichever one you want and stick with it. All right, pause, write down your notes, have a go. All right, we got a bit of an algebra workout there at the end of that one, didn't we? Hopefully you were okay with that. All of those manipulating skills. If you found that difficult, the lesson you need to watch is rearranging formula or changing the subject. That's the one that'll help you with those skills. Whoa, I'm exhausted after that. That was a lot. Right, well done. If you have watched all of this lesson in one go, that is a lot. You have done a lot of work. I'll see you in the next lesson.